Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss surface areas and volumes. In this chapter, we are going to discuss the concepts of exercise 13.5. In the previous class, we have discussed the concepts of exercise 13.4. I hope you have understood the concepts of exercise 13.4 well. And I hope you have done the first 5 sums in the exercise 13.4. Haven't you, my children? Right. Now come to the concepts of exercise 13.5. Are you ready to listen the class, my children? Right. Now let us discuss volume of a object. In this slide, we are going to discuss what is meant by volume of a object. Okay, my children? Right. You have already learnt about volumes of certain figures or certain objects in earlier classes. Haven't you, my children? Right. Recall that solid objects occupy space. The measure of this occupied space is called the volume of the object. Understood this point, my children? Solid objects occupy some space. The measure of this occupied space is called volume of the object. Do you remember this point, my children? Right. Note, please remember this point, my children. If an object is solid, then the space occupied by such an object is measured and is termed the volume of the object. On the other hand, if the object is hollow, then interior is empty. Yes or no, my children? And can be filled with air or some liquid that will take the shape of its container. Yes or no, my children? In this case, the volume of the substance that can fill in the interior is called the capacity of the container. Okay, my children. In short, the volume of an object is the measure of the space it occupies, and the capacity of an object is the volume of the substance its interior can accommodate. Hence, the unit of measurement of either of the two is cubic units. Understood this point, my children? In this point, we are discussing volume and capacity of a container. When we use the word, when we use the term volume, yes, if an object is solid, if an object is solid, then the space occupied by such an object is measured and termed as volume of the object. On the other hand, if object is hollow, then the interior is empty. Yes or no, children? Hollow means interior part is empty and can be filled with air or some liquid that can take some shape of its container. In earlier class, you have studied, suppose milk, oil, we pour in a container. Yes or no, children? Yes. Then the volume of the substance that can fill the interior is called the capacity of the container. 1 liter, 2 liters, they are said to be capacity of the container. Okay, my children, understood this point? Right. In short, the volume of an object is the measure of the solid space it occupies, and the capacity of an object is the volume of substance its interior can accommodate. Understood this difference between volume and capacity of an object, my children? Right. In the previous slide, we have discussed volume of an object. Okay, my children? Right. Now, in this slide, we focus on volume of a cuboid. Okay, my children? Right. What is meant by volume of a cuboid and what is the formula to find the volume of a cuboid? Okay, my children? Right. If we were to talk of the volume of a cuboid, we would be considering the measure of the space occupied by the cuboid. Yes or no, my children? Previous slide we have discussed what is meant by volume of an object. Yes, the measure of the space occupied by the cuboid is said to be volume of the object. Understood this point, my children? Right. Further, the area or the volume is measured as the magnitude of the region. Okay, my children. So, correctly speaking, we should be finding the area of a circular region or volume of a cuboidal region or volume of a spherical region, etc. But for the sake of simplicity, we say find the area of a circle, volume of a cuboid, or volume of a sphere, even though these mean only their boundaries. Understood this point, my children? In this point, we have discussed what is the words area and volumes are used, in which case they are magnitude of a region, area and volume. Okay, my children. So, finding area of a circular region means the circular region is denoting the space occupied by a circle. Yes or no, my children? Similarly, volume of a cuboidal region means the area of the space occupied by a cuboid. Okay, my children. Similarly, volume of a spherical region means it is a measurement of the space occupied by a sphere. Okay, my children, understood this point? Right. Please observe this point, figures, my children, 13.23. Here, a rectangle sheet was given. The same size of rectangular sheets were stacked up one by one. Okay, my children, understood this figure. Then we got a cuboid. In the previous class, at the time of discussing surface area of a cuboid, we have found how to get a cuboid. Yes or no, my children? Right. Observe figure 13.23. Suppose we say that the area of each rectangle is capital letter A. The height up to which the rectangles are stacked is h, and the volume of the cuboid is V. Can you tell what would be the relationship between V, A and H, my dear children? Let us consider the area of this rectangular sheet is A, and the height of the stake is H. Okay, my dear children, and the volume of this solid shape is denoted by V. Then can we find the relationship between these three concepts, my dear children? Right. Now come to this slide. The area of the plane region occupied by each rectangle into height is equal to measure of the space occupied by the cuboid. Yes or no, my children? This is a space occupied by the cuboid. This is a measurement of the space occupied by the cuboid. So we get A into H is equal to V. This is a relation between A, H and V. That is volume of a cuboid. That is volume of a cuboid is equal to base area into height. Here A denotes the area of the rectangular sheet. This is the height of the stack. Then we get the product of these two gives volume of the cuboid. Understood this point, my children? Therefore, volume of the cuboid is equal to base area into height. Understood this point, my children? Right. That is equal to length into breadth into height, because base is in the form of a rectangle. So area of the base is length into breadth. Yes or no, my children? Right. Into height. Understood this point, my children? Right. That is equal to L into B into H, where L, B and H are respectively the length, breadth and height of the cuboid. Okay, my children. Hereafter, we use these three letters L, B, H to denote the length, breadth and height of a cuboid. Okay, my children. Please memorize this formula well, my children, to find the volume of a cuboid. Okay, my children. Right. Note, please remember this point, my children. When we measure the magnitude of the region of a space, that is the space occupied by a solid, we do so by counting the number of cubes of edge of unit length that can fit into it exactly. Therefore, the unit of measurement of volume is cubic unit. Okay, my children. What is the unit of measuring area of a space? Yes, square units. Yes or no, my children? Similarly, the units of measurement of volume is cubic units. Please remember this point, my children. Cubic units is the units of measurement of volume. Okay, my children. Right. In the previous slide, we have discussed volume of a cuboid. Do you remember the formula to find the volume of a cuboid, my children? Yes, length into breadth into height. Okay, my children. Now, in this slide, we are going to discuss volume of a cube. Okay, my children. Right. Observe this figure, my children. 13.24. This is a cube. Here, length A units, breadth is also A units, and height is also A units. Okay, my children. That is why the volume of this cube is equal to edge into edge. That is equal to A cube. Okay, my children. Please remember this point. Volume of a cube is equal to A cube, where A is the edge of the cube. See the figure 13.24. Okay, my children. In the previous slide, we have discussed the volume of a cuboid and the volume of a cube. Now let us take an example to understand these concepts well. Okay, my children, in our daily life, how to use these formulae. Okay, my children. Right. See this example, my children. If a cube has 12 centimeters edge, the length of the edge is 12 centimeters. That is, A is equal to 12 centimeters. Okay, my children. Then volume of the cube is equal to A into A. Yes or no, my children? Understood this step? Volume of a cube formula A into A. Okay, my children? Right. That is equal to 12 into 12 into 12 centimeter cube. This is the measurement of units of a volume of a solid shape. Okay, my children. Units of measurement of volume of the cube. Okay, my children. Here A is equal to 12, and here also A is equal to 12, and here also A is equal to 12. We substituted the value of A in this step. Then we got this step. Understood this step, my children? Right. That is equal to 1728 centimeter cube. By multiplying these three numbers, we get 1728 centimeter cube. Understood this step, my children? Right. Now let us take another example. Okay, my dear children, a wall of length 10 meters was to be built across an open ground. The height of the wall is 4 meters and the thickness of the wall is 24 centimeters. If this wall is to be built up with bricks whose dimensions are 24 centimeters into 12 centimeters into 8 centimeters, how many bricks would be required? Understood this question, my dear children? Yes, we have to build a wall across an open ground. The length of the wall is 10 meters. The length of the wall is 10 meters. And the height of the wall is 4 meters. And width of the wall, thickness of the wall is 24 meters. This is length, this is height, and this is breadth of the wall. Okay, my children. Now, the wall is built up with bricks and their dimensions are also given. Length, breadth and height of a brick. Okay, my children. Now we have to find how many bricks would be required to build the wall. Okay, my children. Right. Now come to the solution part. Since the wall with all its bricks makes up the space occupied by it, we need to find volume of the wall. Yes, my children, which is nothing but a cuboid. What is the shape of a wall, my dear children? Yes, the shape of the wall is a cuboid. Understood this point, my dear children? Right. Here, length of the wall is equal to 10 meters. That is equal to 1000 centimeters. We converted into centimeters. Okay, my dear children. Thickness of the wall is 24 centimeters. And height is equal to 4 meters. That is equal to 4 centimeters. Here we converted the dimensions of the wall into centimeters because the bricks measurements, the dimensions of the bricks are also given in the centimeters. Here, my children, 24 centimeters into 12 centimeters into 8 centimeters. That is why we converted this meters into centimeters. Okay, my children. Here also we converted 4 meters into centimeters. How many centimeters makes 1 meter? Yes, 100 centimeters makes 1 meter. That is why we converted by using that result, the relation between meters and centimeters. Do you remember that relation between meters and centimeters, my children? 100 centimeters makes 1 meter. Okay, my children. Understood this step? Right. Therefore, volume of the wall is equal to length into thickness into height. Understood this step, and this is the formula to find the volume of a cuboid. Length into thickness means here breadth into height. Okay, my children, understood this step? Right. That is equal to 1000 into 24 into 400 centimeter cube. Because here length of the wall is 1000 centimeters and the thickness of the wall is 24 centimeters and the height of the wall is 400 centimeters. We substituted these three values in this formula. Understood this step, my children? We wrote at the last of this step measurement of the volume of a cuboid. Okay, my children? Understood this step? Right. Now, each brick is a cuboid with length 24 centimeters, breadth 12 centimeters, and height 8 centimeters. These are the dimensions of the brick, dimensions of a brick. It is in the form of a cuboid. Okay, my children, understood this step? Right. So, the volume of each brick is equal to length into breadth into height. Okay, my children, here also we used the formula to find the volume of a cuboid, length into breadth into height. Understood this step, my children? Right. That is equal to 24 into 12 into 8 centimeter cube, because here length of the brick is 24 and breadth of the wick is 12 centimeters and height of the brick is equal to 8. Understood this step, my children? We substituted these three values in this formula. Then we got this step. Okay, my children. At the end of this step, we wrote centimeter cube because this is a measurement of volume of this brick. Okay, my children. Understood? Right. So, number of bricks required is equal to volume of the wall whole divided by volume of each brick. Okay, my children. So, by using this formula, we can find the number of bricks required to build the wall. Understood this step, my children? Right. That is equal to, what is the volume of the wall? 1000 into 24 into 400 whole divided by volume of a brick 24 into 12 into 8. We substituted these two values in this step. Then we got this step. Understood this step, my children? Right. Now let us simplify these numbers. What will you get here, my children? Here 12 table, here 24 gets cancelled. Yes or no, my children? 24 gets cancelled. Here 8 one times, 8 one time, 8 50 times, 8 5s 40. Okay, my children, 50 times. Similarly here 2 table, we can strike out with 2 table or 4 table. 4 3 times, 4 3 times, here 4 250 times. Okay, my children, right. So what will you get here in the numerator? 250 into 50 whole divided by 3. Yes or no, my children? Right. That is equal to 4166.6. By simplifying these numbers, can you multiply these two numbers in the numerator, my dear children? 250 into 50. Then what will you get? 1250. Okay, my children. Let us multiply these numbers, these two numbers. That is equal to, what will you get? 25 fives. What will you get here? 125. 125. 2 zeros. Whole divided by 3. Understood this step, my children? By multiplying these two numbers, we get 12,500 in the numerator divided by, in the denominator, only 3 is there. Okay, my children. Now divide this 12,500 by 3. What will you get here? 4,166.6. Understood this number, my children? Right. So the wall requires 4,167 bricks. Okay, my children, because here decimal point is there, 0.6 is there. So we have taken as 4,167 rounded figure. We have rounded this number into whole number, into a whole number. Understood this number, my children? Right. Now let us take another example. Okay, my children, a child playing with the building blocks which are of shape of cubes has built a structure as shown in figure 13.25. If the edge of each cube is 3 centimeters, Find the volume of the structure built by the child. Understood this question, my children? Right. Please observe this figure 13.25. Here, a child is building blocks. These are blocks. Okay, my children. Each block is in the shape of a cube. Okay, my children. Observed here this point. Each block is in the form of a cube, and the edge is 3 centimeters length. Its length of the edge is 3 centimeters. Then we have to find the volume of this structure. Understood this question, my children? Right. Now come to the solution part. Volume of each cube is equal to edge into edge into edge. Means side into side into side, or A into A into A. Understood this step, my children? Right. That is equal to 3 into 3 into 3 centimeter cube. We have substituted the edge of the cube in this formula. Understood this step, my children? Right. That is equal to, by multiplying these three numbers, what will you get? 3 into 3 into 3, 27 centimeter cube. Understood this step, my children? Right. This is the volume of each cube. Okay, my children. Now, how many cubes are there in this structure? Please count them. Number of cubes in the structure is equal to 15. Yes or no, my children? See, observe here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 15 cubes are there. So, total number of cubes in the structure is 15. Understood this step, my children? Right. Therefore, volume of the structure is equal to 27 into 15 centimeter cube. Understood this step, my children? There are 15 cubes are there, and the volume of each cube is 27 centimeter cube. Therefore, the volume of the structure is equal to 27 into 15 centimeter cube. Understood this step, my children? Right. That is equal to 4,405 centimeter cube. By multiplying these two numbers, what will you get here? 405 centimeter cube. Understood this step, my children?